So let me explain what is transient behavior and initial conditions. So introduction. Whenever a network containing energy storage elements, that is such as inductors or a capacitor, is switched from one condition to another, either by change in applied source or change in network elements, the response current and voltage change from one state to another state. So that we are going to explain with a simple circuit how inductor and capacitor actually behaves. Okay, whenever you change the switch from one state to another state, how it going to behave, we're going to explain in the this topic. And the time taken to change from an initial steady state to final steady state is transient period. So what is transient period is, it is a time taken to change from initial steady state to final steady state. It is called as transient period. This response is known as transient response or simply transients. The response of a network after it attains final steady state value is independent of time and is called steady state response. And the complete response of the network is determined with the help of differential equations. Let me explain with some example. So if you take a simple RLC circuit and if I give a step input, how the output changes. Okay, so this is the time, x-axis is the time, CF is the output. If these are step input, and output will not reach immediately the steady state value. This is the steady state value, and this is a transient time. So this period from 0 to this much is transient time. After that, the system will reach steady state, and it is called as steady state time. And the duration from 0 to when it reaches steady state, this period is called as transient time. And you can see here little bit, you can see due to storage elements, capacitors, inductance. So you may get like transients like this. After that, the system will settle down and the steady state will be reached. So this time is called as transient time. After this, it is steady state of the system. So let us have some definition here. The steady state, the study of behavior or the study of response of a system with respect to time is actually time response analysis. It is divided into two parts. The transient part. So this part, you can see the waveform here. The transient part is this, and steady part is remaining. Okay, transient part where the transient will takes place. Okay, that is because of energy storage elements present in the circuit. Note, transients are due to energy storage elements. That is the thing, but capacitors and inductors present in the system and its initial values. Suppose if any capacitor is already having some initial voltage, and in inductor already some initial current is flowing, and that all actually results in this type of transients, and finally it will reach steady state. So one more, natural response means energy stored released to the resistive part of the network. That is, energy stored in capacitor is related to resistive part of the network. Okay, that is actually natural response, or we can also give external energy where we call it as forced response. So suppose, okay, consider one small circuit here, simple circuit, one resistance and one capacitor. If resistor is alone, okay, then if I give any voltage, immediately output will have steady state, immediately it will come. But if there is a capacitor, output will not reach immediately to that value. We are given Vs, and capacitor will try to charge this voltage Vs, and that immediately it will not charge, it will take some time. You can see the charging of capacitance, and x-axis is time constant O, and output, this is a Vs is the output, and this period is called as transient period, where capacitor starts from 0 to it will reach maximum of Vs it will reach approximately 98%, okay, of Vs, and this is called as steady state is reached. Once steady state is reached, okay, it is output is constant here, and this is the transient period, because whenever I close the switch, Capacitor value will not immediately reaches this one. It will take some time. So that depends on time constant of the given circuit. Rho is equal to actually RC. And the time actually divided into three parts here. This is x-axis. At t is equal to 0, the switch is closed. At t is equal to 0, the switch is closed. This part is called as, so this point where the switch is closed, that is called as t is equal to 0 plus. And for all the time beyond that, that is before switching action takes place, we can take t is equal to minus infinity here. Okay, you can take t is equal to minus infinity, that minus infinity to t0. Okay, minus infinity to t0, it is minus infinity to t0, it is called as before switching. T is equal to 0 plus is just switching, and for all the time greater than after switching we call it as, okay, after switching. So time is divided into three parts: before switching, just after switching, and after switching. Just means at that just instant. Okay, for t greater than 0, it is after switching. And capacitor voltage is given by, you can see the voltage Vc of t at any point of time is given by 1 by c integral of minus infinity to infinity I of t dt. So minus infinity to 0 I of t dt, and 0 to infinity. You can split that minus infinity to infinity to 0, minus infinity to 0, 0 to infinity. So before, if any capacitor is already charged, if already capacitor is charged before switching, then we call it as, okay, initial voltage of the capacitor Vc of 0 minus, because before switching only capacitor is already charged. After that, whatever it will charge, okay, that is actually t greater than 0, it is going to charge. That is given by 1 by c integral of 0 to infinity I of t dt. So please remember, for uncharged capacitor, if capacitor is not initially charged, Vc of 0 minus is 0, and just after switching capacitor voltage is also 0. And equivalent circuit, just after switching capacitor acts as short circuit. You remember capacitor as your mobile battery, because whenever you charge, whenever you put your mobile battery to charge, it will start charging. For charging, actually short circuit should be there. If open circuit means no current and capacitor is not going to charge. So in order to charge, there should be a short, that is, a circuit should not be open. It is act as a short circuit, and capacitor start charging. So capacitor acts as short circuit, okay, just after switching. Just you have to remember, and remember that if your mobile battery is already charged, okay, some initial voltage of some 50%, and if you put it to charge again, it will start from, it will act as a short circuit, and it will charge to reach 100%. Okay, so any point instantaneous voltage of the capacitor time t is given by initial voltage, that is before switching how much voltage is there, plus 1 by c integral of 0 to t I of t dt. You remember, just after switching capacitor acts as short circuit. You analyze that, you can consider your mobile as a battery. Your mobile battery is there, no, that you can consider as a capacitor, because that is also charging. Your mobile battery is also charging. Whenever you switch on, okay, immediately it should charge. So that's why it should act as short circuit. Okay, so similarly, if switch is if there is no, okay, if there is no power supply, just already if initially charged capacitor is there and there is a closed path, if any open circuit is there, capacitor will hold that value. If any closed path is there, then capacitor try to discharge. So this is the discharging time. Okay, capacitor is already reached to Vs. Once you close the switch, okay, short it, okay, then capacitor will start discharging. Okay, so through this R it will discharge. So this is that slowly capacitor loses its charge, like your mobile. When you are using your mobile, okay, it's going to discharge. Your battery becomes 98%, 90%, 80%, like that. Now slowly it will discharge. Okay, so this is Vc of 0 minus. Suppose before switching some voltage is there, immediately after switching, still capacitor will have that value Vc of Vc volts. If you give some time, it will discharge some amount and it will lose some amount. Okay. So next, we have inductor, how inductor behaves. So current through inductor cannot change instantaneously. See, current through inductor cannot change instantaneously. Current through inductor cannot change instantaneously. So you can see IL of t is equal to 1 by L minus infinity to infinity V of t dt. 1 by L minus, again you have to split that minus infinity to infinity as minus infinity to 0, 0 to infinity. IL of t is equal to, this is initial current in the inductor, and for t greater than 0, 1 by L into V of t dt. Suppose if any, immediately after switching, since current in the inductor cannot change instantaneously, so current is equal to 0 in inductor. IL of 0 minus is 0. Okay. For uncharged inductor, it acts as the IL of 0 minus is 0 amperes and IL of 0 plus is also 0 amperes. 0 amperes means open circuit. So inductor acts as open circuit. Equivalent circuit, just after switching, inductor acts as open circuit. Suppose initially some current is flowing in the inductor. Initially some current I is flowing in the inductor. So that I, immediately it cannot become 0. So just after switching also it acts as a current source of which is already flowing in the inductor, not new current. Suppose already new some current is flowing in inductor, just after switching also it acts as that. So now you should know the voltage relations between in the inductor, capacitor, and in resistor. What is the relation between? What is the equation for voltage and current in resistor and inductor? In a resistor, okay, V is equal to IR. That is Ohm's law. So V of t means at any point of time t. So V of t is equal to R is constant, R into I of t. V is equal to I into t. V of t is equal to R into I of t. And similarly, I of t is equal to V of t by R. R is constant. I of t is instantaneous value of current. V of t is instantaneous value of voltage. So V is equal to IR. I is equal to V by R. That is for resistor. For inductor, voltage is given by L into di by dt. For inductor, voltage is given by L into di by dt, and current is given by I of t is equal to 1 by L integral of V of t dt. For a capacitor, voltage is given by 1 by C I of t dt, and current in an inductor is given by I of t is equal to C into dV by dt. So if you remember this equation is very, very important. For all the circuits for t greater than 0, we are going to apply KVL. So you have to use this. If you make any mistake, you will get wrong answer. Well, remember, in resistor, V is equal to IR. Remember Ohm's law. For inductor, L into di by dt for voltage. And for capacitor, voltage is 1 by C integral of I of t dt. And observe here, current and voltage relation in inductor and capacitor. For inductor, voltage is V of t is equal to L into di by dt. For a capacitor, I of t is equal to C into dV by dt. Okay. For a capacitor, I of t is equal to C into dV by dt. See here, for inductor, voltage is L into di by dt. For capacitor, current is IC is equal to C into dV by dt. Similarly, for capacitor, voltage is 1 by C integral of I of t dt. And for inductor, IL of t is equal to 1 by L V of t dt. So you have to remember this important formulas. Now, how your circuit behaves, okay, based on the previous topic. So this is very, very most important able. If you remember, for all the problems you require this. If you remember this, I think that you'll get 10 marks easily. So this is important, both full slide, okay, important slide, don't forget this. So how your circuit elements behaves, okay. So time is divided into three parts. I already told. Okay, time is already told. So before switching is t is equal to minus infinity to t0 plus. That is t0 plus is just after switching. So from t minus infinity to t0 plus, that is called as before switching. Just after switching is t is equal to 0 plus. And for t greater than 0, it is steady state. Okay. Okay. Now let us write how circuit elements behaves for t is equal to 0 and t is equal to infinity. Resistance remains unchanged. Resistance is R only. Here also it remains resistance only. No changes in its behavior. Coming to inductor, it is very, very important. So inductor just after switching, it acts as open circuit. Condition is no initial current should flow in this. If any initial current is flowing, suppose I naught is already flowing in inductor, you have to, instead of open circuit, you have to write current value of that I naught. Okay. And when t is equal to reaches infinity, okay, after switching, okay, steady state is reached, then capacitor acts as open circuit and inductor acts as short circuit. Inductor acts as short circuit. Now let us go to the capacitor. In the capacitor, just after switching, it acts as short circuit. When steady state is reached, it acts as open circuit. Now again, I will explain one more here how to remember this. In the exam, you'll get confusion whether capacitor is acts as short circuit or inductor acts as short circuit. You'll get some confusion. So remember, in capacitor, you consider as your battery, okay, your mobile battery. So assume that your mobile battery is not charged fully, it is drained and it is 0%. Whenever you charge, whenever you switch on, okay, you are going to plug into the power supply and switch on. Immediately it is going to start charging now. So that's why it should be short circuit and current should flow through the capacitor and it should start charging. So it should act as a short circuit. If it is acts as an open circuit, okay, suppose if you write it this as an open circuit, your battery will not at all charge, your capacitor will not at all charge because of open circuit, capacitor is not going to charge. So that's why how to remember means if your capacitor is not having any initial charges, just after switching, okay, capacitor acts as a short circuit and it will start charge. Okay, once it charges fully, it acts as open circuit. Why is, for example, consider some voltage source. Okay, okay, once we switch on, okay, here switch is there. Once you switch on, now capacitor start charging. So that's why it acts as a short circuit and it will start charging and current flow through this. It will start charging with polarity plus here minus here. And suppose this is V. Capacitor also reaches maximum voltage of V. Now here supply voltage is also V. This is also V. What is the potential difference? V and V. And there is no potential difference because this is also at V, this is also at V. Because capacitor reaches fully maximum. No more current will flow. So that means capacitor acts as open circuit. Because it is fully charged, no? There is no potential difference, no current. That means capacitor acts as open circuit. Whenever steady state is reached, capacitor is fully charged to that voltage value and no more current is flowing through the capacitor and it acts as open circuit. This is how you have to remember. For example, in case of some batteries, if you are plugging your mobile batteries to charge, once it reaches 100%, okay, you can observe in the power point it becomes a red color or initially it will be green and finally it will becomes uh, that indicator will off. That means no charging is take place. It acts as open now, no flow of current in that. So once it reaches maximum, it acts as, that means whenever 40 greater than the infinite, from greater than 0, once it reaches infinity, that means steady state is already reached. Capacitor acts as open circuit. For t is equal to 0, capacitor acts as t is equal to 0 plus. Just after switching short circuit, in the steady state, it acts as open circuit. Opposite for inductor. Initially, it acts as open circuit. When steady state is reached, it acts as short circuit. Okay. Suppose initially some voltage is there in the capacitor. That means your mobile battery is already charged with some 25% or 30%. Then, if you again put into the plug, then what happens? it will start charging from 30%. So initial voltage also will be there. Initial voltage is also will be there, and it will act as a short circuit, and it will start charging continuously. Once it reaches again, steady state is reached, capacitor will reaches its maximum value, and it acts as open circuit. Suppose if additional external power supply if you give, it will start reaching to that maximum value, and it will acts as open circuit. So just remember this time, once again I will repeat. Capacitor at t is equal to 0 acts as a short circuit. For t is equal to infinity, that means steady state is reached, acts as open circuit. Condition: initially capacitor should not have any initial voltage. If any initial voltage is there, for t greater than at t is equal to 0 plus, that means just after switching, capacitor acts as voltage source of that initial voltage and acts as a short circuit here. Between this point and this point, it acts as short circuit. Once steady state is reached, it acts as voltage value and acts as open circuit. Okay, next, if in the inductor, just after switching acts as open circuit, for t greater than for t is equal to infinity, it acts as a short circuit. If any initial current is flowing in inductor, it acts as a not open circuit. It acts as the initial current of that initial value. And for t is equal to infinity, it acts as current source parallel with short circuit. Here it is series. For capacitor, voltage source in series with open circuit. Here current source in parallel with short circuit. So this table is very very important. And one more table is this: voltage and current in a resistor, inductor and capacitor. V is equal to IR, I is equal to V by R for resistor. For inductor, voltage is V of t is equal to L into di by dt. Current is 1 by L integral of V of t dt. For a capacitor, see for what you write for current, no, that is for capacitor now here. Voltage V of t is equal to 1 by C integral of I of t dt. Okay, and I of t is equal to C into dV by dt. So here voltage for inductor is L into di by dt. Here current for capacitor is C into dV by dt. If you remember this, any problem you can solve and easily you can get 10 to 10 marks minimum. I think both the problems if you solve you will get 20 marks. Otherwise minimum 10 marks you can easily get from this module. So next we'll do problems in the next slide. So in the next video I'll explain how to solve problems. So just remember this table. It's a very very important table. Thank you.